the screw. This is the Y screw. And this is going to be fitted on the underside of this plate, this cross member. And I thought I'd screwed up with the design of this, but as it turns out I haven't. Originally I was going to have the screw around this way with the, there's a dual, better take that again. Now, this end here is where the dual bearing goes on. Now this has two opposing bearings in here. That when you preload them, when you do them up via a nut on the end of this shaft, it sort of loads the bearings up to stop the whole shaft going back and forth like this. You see, that's the idea of it. It works very well. I was going to have this out on the front, and I wasn't going to have any bearing at all on the back, and I was just going to put the stepper motor directly on the end of this shaft in reverse. Well, it turns out that I can't. And as it happens, it has worked out with my measurements perfectly to go around the proper way, which is the dual bearing up this end, which is the back, where the stepper motor is going to be on the back, and then this bearing, this is the front bearing, it's a single bearing, is going to be just outside on the front here. So to enable all that to happen, I have to drill or cut a hole. So I need to cut a hole in this 1/2 inch thick aluminium, clearance size for this coupling to run just inside, because it turns out this is going to be just about like that. So that means this coupling is going to be just on the inside of this, and then I'll build a housing over this, like you've seen me do in the X2 mini mill and the lathe. It's a very similar sort of coupling arrangement, works very well. So that's what I'm going to do. So you don't have to have a drill this size. What you need is a relatively good quality hole saw, and that's what this is. It's the right size. As you can see, right size, gives enough, pretty well the exact amount of clearance. If there's, if it requires another 1/2 millimeter or something, you can get something like a Dremel and just run around the inside of the hole, just take it out that little bit, or a file. So that's what we're going to do now, drill the front and the back. I have to drill the other end because the whole screw is going to go out through the front very slightly. So the next thing is how to hold this whole chassis arrangement. Well, you can clamp it down on your bench, if you wanted to, make a couple of blocks of wood and screw it to your bench, or just get a block of wood and clamp it one end of your bench and drill the other end, and then swap it around afterwards, which is the easiest method to do, and it's what I'm going to use. So let's get this out of the way and we'll drill it. Okay, so we have our holes now out to the right size, which is, in this particular case, 30 millimeters or 1.2 inches. Okay. So the next thing you need to do, when you know that this is square, all right, you check to see if it's square by going from corner to corner, like that, and it should be within, well, I've got it within 0.5 millimeter. Which is fine. For a CNC router, that's pretty damn good. If you want to get it better than that, you know, that's up to you. But you'd have to sort of file a little bit off one corner or the other. You'd have to find out which one was, you know, sort of that much out of square, and it's really not worth it when you're talking about CNC routers. So the next thing to do then is, when you've got everything tightened up, alright, so you've got like 3 bolts on each corner, when you've got them all up nice and snug, is to check the squareness. Now I'm checking that off this bench. I know this bench is dead flat. It's nearly, well, 2.5 inches. It's over 2.5 inches thick, okay, of layered plyboard, and it is dead flat. So I'm quite happy to check for something to be square off this. Now, when you do this both ends, as you can see, it's pretty damn square. Now, for me to get it that square, I actually needed, in that corner there and in that corner there, up on the top section, you see that little bit of brass? That is a 0.02 of an inch piece of shim, shim steel, shim brass actually, that I've just put there and tightened up on that, because that then brought these up to square. And that's really important for these to be square, because you're going to be mounting a bearing, you know, these bearing blocks on the face of these, and you know, when you do it up tight, it's just going to tend to jam things up if it's not square. So that's, you know, important to be square. Now the next thing, which is important, is now this cross member, which is going to be driving the gantry. The gantry is going to be built off this. This now needs to be square with these and this. And to check it, it's easy. You can do it by sight. Okay, there shouldn't be any sort of gap in here at all. Nice and square. And of course, the same that end, nice and square. And it's at that point you are ready to mount this back on, and we are going to line up the bearings and do the drillings for the, let me pick this one up, to mount these bearing blocks on each end, okay? And you know, you have to do it with this bolted onto here, okay? And offer it through and offer the bearing on, then pilot your holes. I'll show you how to do that. So I've mounted the bearing on this cross member now. It's all tightened up. Screws in. The end of the screw shaft is into this bearing housing, and I've got a little block of wood here just holding this from turning round, and I'm just going to now pop a drill through here now, just to mark, and then I'm going to drill it a tap-in size. First of all, I'm going to put a clamp on it to stop it sliding around. Okay. And if you've got everything right, these bearing blocks should tighten up. What I'm actually going to do is I'm just going to nip up 2 on this end. I just want to pull this down this way before I do that. Bring this down. So you can tighten up the bearing block in a position where you know that it's absolutely in the right position. Oh. I think I should have put a stepper motor on this. Well, there's no sign of any binding or anything there, so I'm just going to tighten up these 2 top ones. Oh, free, lovely. Get this out the way. There's a quicker way of doing this, of course. much better way of doing it. Okay, so when you've got everything tightened up, all the bearings tightened, everything tightened up, and all nice and square, your y-axis is pretty well complete, other than having the stepper motor put on here, which is a fairly simple job, and putting a y-axis limit switch on, which I'll do right at the very end after everything's built. So you should have a free running y-axis like that. So there you go, that's how to build a y-axis on this, my design, which is the AMAX CNC Router. You can see it's beginning to take shape now, and it's a fair size unit. So the next video now is going to be building the gantry up here and the x-axis. I'll probably be able to get that done in one video, but we'll see what we can do. If you've liked this video, and I'm sure you have liked the video if you've got this far, please like and subscribe, and if you like what I'm doing, you may consider becoming a patron to the channel, because it is the patrons behind this channel that allow me, that fund me doing these builds, and all the specifications, the drawings, and all the parts and the vendors will be available on my Patron pages. So thank you for joining me, and I hope you join me on the next video for the gantry and the x-axis build. So it's bye for now.